Welcome to IDS-IT. Let's explore an important topic shaping the future of defense and global security. I'm the founder and director of International Defense Security and Technology, a California-based nonprofit think tank dedicated to research and analysis on global defense, security, and emerging technologies. I also serve as CEO of Interplanix LLC, a New Mexico-based company advancing satellite risk analysis, orbital debris forecasting, and space security frameworks to ensure mission assurance and resilience. Previously, I served in leadership roles at India's Defense Research and Development Organization, DRDO. Most recently as Director of the Systems Analysis, Modeling, Safety, and Quality Cluster at DRDO Headquarters, New Delhi. This channel brings you deep insights into the global security ecosystem, from geopolitics and emerging military technologies to cyber, space, and system-level analysis of tech trends and their interrelationships. Subscribe and join us as we decode the forces shaping the future of global defense and human security.
Today we are diving into the cutting-edge technology that's quietly powering humanity's most ambitious dream, reaching Mars. It's not just about rockets or astronauts. Behind the scenes, supercomputers are playing an absolutely critical role in making our journey to the red planet possible. Let's start with the problem. Mars is hard. Really hard. Its atmosphere is just 1% as dense as Earth's, which makes landing spacecraft a nightmare. Parachutes barely work, but the thin atmosphere still generates intense heat during entry, so we need heat shields too. The solution: retropropulsion, firing rockets in reverse to slow down. But how do we know it'll work on Mars, when we can't fully replicate those conditions on Earth? That's where supercomputers like Summit and Frontier come in. These machines simulate the physics of descent in unbelievable detail. They model how rocket exhaust interacts with the thin Martian air, how turbulence affects the craft, and how guidance systems need to adjust in real time. NASA's been using these simulations to refine every aspect of entry, descent, and landing down to the second. But that's just the beginning. Once we land, astronauts will face an alien environment, massive temperature swings, dust storms, and radiation with no global magnetic field to shield them. Again, supercomputers are the key. They're helping us model life support systems, habitat designs, even how Martian dust might accumulate on rovers or solar panels. These aren't just theoretical ideas, they're virtual test beds helping engineers optimize equipment before it ever leaves Earth. And what about the science? Searching for life, analyzing soil and rock samples, mapping underground water, these all involve processing huge volumes of data. Supercomputers sift through it all to find patterns, model climates from billions of years ago, and identify places where microbial life might once have thrived or still does. Let's not forget health and safety. Long-duration space travel to Mars means months of microgravity, radiation exposure, and isolation. Supercomputers are helping researchers simulate how the human body reacts over time and develop the medical protocols, exercise plans, and psychological support needed to keep astronauts healthy mentally and physically. Then there's the issue of communication. A signal from Earth can take up to 24 minutes to reach Mars. That means no real-time control. So future missions need AI systems that can operate independently, make decisions, and adapt to emergencies. Supercomputers are training these AI systems right now, running thousands of simulations to prepare for anything Mars can throw at us. At the heart of all this is Frontier, the world's first exascale supercomputer. It's capable of performing a quintillion calculations per second. That's more than every human on Earth doing math non-stop for billions of years. And it's being used to simulate every stage of Mars exploration, from rocket propulsion to habitat oxygen flow to predicting solar radiation events. Without this level of computational power, many aspects of a Mars mission would be guesswork. But with it, we can prepare with confidence, refining every component, training every system, and protecting every astronaut before the rocket even leaves the pad. So the next time you picture the first humans stepping onto Martian soil, remember, before the boots, before the rockets, it all started inside a supercomputer.